Welcome to The Explainer. Today, we're pulling back the curtain on a piece of tech that is pretty much reshaping our entire world: machine learning. All right, let's jump right in.
So, here's what we're going to cover. First, we'll look at the magic you already use every day. Then, we'll see how computers actually learn. We'll check out the three main teaching styles, a huge challenge called learning the right lessons, and finally, we'll see how ML is, well, everywhere.
Okay, so let's kick things off with something you've probably noticed but maybe never really thought about. I mean, really, have you ever wondered how your Netflix queue just knows? Or how Google Maps tells you there's a traffic jam up ahead, like minutes before you even see it? Or how your email inbox is so good at catching spam? It almost feels a little psychic, right?
Well, that psychic feeling? It's all connected. It's the same tech behind those amazing spam filters, those traffic predictions, and even when Facebook perfectly suggests which friend to tag in a photo. It is the invisible engine that makes our digital lives feel so personal.
So, what is this invisible engine? How in the world are computers actually pulling this off?
The answer, simply put, is machine learning. That's the secret sauce. That's what's behind all of that digital magic.
But what does that fancy definition actually mean? Well, the key phrase here is learn and improve from experience. Think about it. Instead of a programmer having to write a billion lines of code for every single possibility, we create systems that can just figure it out. They look at data, find patterns, and learn all on their own.
And this quote just hits the nail on the head. We're trying to give computers a skill that comes totally naturally to us. We learn by doing, by observing, by making mistakes. And that's exactly what we're teaching machines to do.
And that learning process follows a pretty logical path. First, you need data, a lot of data. Then you use that data to train your computer model. After that, you've got to test it, see if it actually learned anything useful. And finally, you set it loose in the real world where it can keep on learning and getting better.
Okay, so how does the training part actually work? Well, just like there's more than one way to teach a person, there are a few different ways to teach a machine. Let's call them the three main teaching styles. First up, you've got supervised learning. The best way to think about this is like learning with a teacher who gives you the answer key. You feed the machine a huge amount of data that's already labeled with the right answers, and its job is to figure out the patterns. For example, you could show it thousands of photos, each one labeled either dog or cat. After seeing enough of them, it starts to understand the features of a dog versus a cat. That spam filter we talked about? Same idea. It learns from millions of emails already marked as spam or not spam.
Next, we've got unsupervised learning. With this one, the teacher basically walks out of the classroom. You give the machine a massive pile of data, but this time there are no labels, no answer key. Its job is to dive in and find its own hidden patterns.
Imagine giving a computer a big, messy box of different fruits and just saying, sort these. You don't tell it what's what. It might start grouping them by color, or by size, or by shape. It discovers the categories all by itself. This is actually how systems like Netflix can find weird little groups of people who all love the same obscure documentaries. And our third style is reinforcement learning. This one is all about learning from trial and error. You have an agent, think of it like a player in a game, and it learns by doing things and getting feedback, either a reward for doing something good or a penalty for doing something bad. The classic example is an AI learning to play a video game. At first, it's just mashing buttons randomly, but when it scores points, it gets a digital good job and learns to do that move more. When it loses a life, it gets a penalty and learns, okay, yeah, don't do that again. After playing millions of games, it can become better than any human player.
So, to just quickly recap here, the big difference between these three is the data. Supervised needs labeled data with the answers. Unsupervised works its magic on unlabeled data to find patterns. And reinforcement learns on the fly from a feedback loop of rewards and penalties. Each one is a tool for a different kind of job.
But, it's not always so simple. You can't just throw data at a computer and hope for the best. You've got to make sure it's actually learning the right lessons. And that can be tricky.
This leads to a fascinating problem. What happens when a model gets too good at studying for the test? So good that it doesn't just learn the concepts, it memorizes every single word in the textbook, including all the typos and mistakes.
Well, in the world of machine learning, that's a huge problem called overfitting. It's when the model basically just memorizes the training examples instead of learning the general rules. And because of that, it's brilliant at the stuff it's already seen, but it totally fails the second you show it something new.
So the goal is always good learning, which is about generalizing. It's about taking the core ideas and applying them to new situations you've never seen before. Overfitting is the opposite. It's just memorization. It's brittle, it's inflexible, and it's something engineers work really hard to avoid.
Okay, so now that we get the basics of how machines learn, and even some of the challenges, let's zoom back out. Because when it's done right, this technology is truly, and I mean truly, everywhere. And we're not just talking about movie recommendations anymore. Machine learning is the engine running self-driving cars. It's helping doctors spot diseases earlier in medical scans. It's detecting credit card fraud the instant it happens. It's even refining your search results on Google. It's not sci-fi anymore. It's just infrastructure.
And that really brings us to the final big idea. At its heart, machine learning is about teaching a computer to find patterns and make decisions. So, now that you know the basics of how to be the teacher, I'll just leave you with this one question. What's the next big, incredible, world-changing problem you would teach a machine to solve?